Hello everyone, this is the video made for class 9th students regarding the chapter Euclid's Geometry. So the geometry, where this word has come actually. This word has come from two Greek words. One is geo, which means earth, and the other one is metrin, which means to measure. So geometry mostly developed in Egypt country only. This is a small story about geometry, why it was mostly developed in Egypt country only. Because of most of you heard a river name as Nile. It is the some biggest river in Egypt or something world. Also some of the biggest river. So in olden days, it used to overflows every time. So when the river overflows, the boundaries of the houses, whatever the Egyptians are constructed, and the fields also, we know that all of our fields also having some boundaries in the shape of rectangle or square like boundaries it is going to have. At the time, all these boundaries are going to be erased, so that again the Egyptians were used to construct the boundaries again and again. So these many times, to construct the boundaries exactly, they need some particular measurements, they need some particular objects. So they were developed up some of the objects in geometry like point, line, plane, and some of the basic shapes like that. The geometry was developed mostly in Egypt country. So in that Egypt country only one mathematics teacher is there. His name is Euclid. So this Euclid is known as father of geometry. He wrote 13 books on geometry, which are called elements. So although he written the 13 books on geometry, he is not able to define three terms. Those are point, line, plane. These three he is not able to define, because of if he want to define those three terms, again you need the help of some other terms. So these three are not able to define by Euclid. So these are called undefined terms of geometry. But without these terms, there is no geometry. So these are called basic building blocks of geometry. And Euclid defined axioms and postulates. They are assumed to be truth, universal truths. They are not required any proof also. What are that? Axioms and postulates. He is only Euclid. This is the book written by Euclid. Total 13 books like this he wrote. Those are called elements. Okay. Now axioms. So as I told you, axioms are assumed to be true. There is no option. Okay. Then they are not required any proof also even. So in that the first axiom is things that are equal to the same things are equal to one another. So this is the first axiom. Even I'll give the examples in the next slide. And the second axiom is if equals are added to the equals, the wholes are equal. And coming to the third axiom, that is if equals are subtracted from equals, then the remains are going to be equal. And coming to the fourth axiom, it is things that coincide with one another are equal to each other. And next fifth axiom is the whole is greater than part. Sixth axiom, things which are half of the same things are equal to one another. And seventh axiom, things which are double of the same things are equal to one another. See, in exam, maximum of the exams that we are conducting in school are some of the papers issued by CBSE regarding this chapter, mostly they'll ask these axioms or else the postulates. So you need to concentrate on axioms. Learn at least 5 axioms. No need to be in order, but learn the axioms. So here I'll give the examples for 5 axioms. So first axiom, as I told you, things which are equal to the same things are equal to each other. So here I am taking three things, A, C and B. Here I know that A is equal to C and C is equal to B. So these two are equal, these two are equal. See, this A and B both are equal to C only. So we can say that A and B are equal because things which are equal to same things are equal. And coming to the next one, things which are coincide with one another are equal to each other. Take any of your ninth class maths textbooks, any two ninth class maths textbooks you take and place one on other. They are going to be exactly coincide with each other or not, you check. So we can say that they are going to be coincide with each other. So things which are coincide with one another are equal to each other. Are coming to the third one, if equals are added to the equals, wholes are equal. So here you see I am taking two values A and B, both are equal. I am taking they both are equal. I am taking like that and I am adding some element C both the sides, this side and this side. Then whatever I am getting that are going to be equal. So this one and this box is going to be equal because of A and B are equal. I am adding equals to them. So whatever the result that I am going to get, that are going to be equal. And coming to the next one, if equals are subtracted from equals, remains are equal. Here I am taking some two objects. These two are equal. I'll consider these two are equal. So I am taking some of the part here and here. Equal parts I am taking out. So whatever the portion is going to left, that is going to be equal. So this one and this one are going to be equal. So if you subtract equals from equals, the remains are equal. And the last one, whole is greater than part. You take any whole object, from the total object you take a part of object. So always we have to obey that the whole is greater than the part. For example, take one cake, divide into four parts, take one of the part. That whole cake is always greater than the part. And coming to the next one, postlets. Euclid also defined 5 postlets. So here you can see the classwork also. I gave this all 5 postlets with pictures. So first postlet is a straight line can be drawn from any point to other point, any point. Next, second one, finite straight line can be produced continuously in a straight line. So if you want to produce the straight line, you can extend both sides continuously. And we can draw any circle with any point and any radius. We can draw a circle, any point as center and with any radius you can draw. And coming to the fourth one, all right angles are equal to one another. All the right angles, you take any right angle or some other right angle in some other picture, all the right angles are going to be equal to one another. Last one, if a transversal falls on two straight lines which are not parallel, compulsory they are going to meet at a point where those two straight lines are not, where the two straight lines are going to be meet. They'll meet on the side of transversal, on which side the sum of co-interior angles is less than 180. See, so there, that side, the two lines are going to be meet. Okay, that is about the fifth postulate. And these are the real life applications. So you can go through this because of it is very important subject in our daily life even. For example, if a sports car is moving in a circular path and it applies the concepts of geometry, because of circle is defined from geometry only. Okay. And next, stairs. When you your stairs in your home must be inclined with 60 degrees angle, with each stair designed at 90 degrees. And simple cloth hanger that should follow these measurements of angles, or else you can't use the cloth hanger. And next one, ceiling fan. It is going to be have 3 blades, and each and every blade have to be inclined with some 120 degrees angle with the next blade. So this should be done. Then only we'll get air from the fan. And next one, any object when thrown at 45 degrees angle, it covers maximum distance. If you want to throw an object to maximum distance, you are supposed to throw the object with 45 degrees angle, then only it will cover maximum distance. And coming to the geometrical shapes, they are mostly used in by the artist, and also most of the historical buildings, they were constructed by using of this geometrical shapes only. So thank you everyone, go through this video and read axioms and postulates and practice the problems which are related to axioms and postulates. Thank you.